if we look at the following function here, they say g is a cubic function. That's number one. And then if g is a cubic function, here are the properties of g. They just gave us the properties, and then we're going to draw based on the properties. Number one, they're saying g of 3. What does that mean? It means which x is 3. And then what is y? They gave you which when x is 3, our y is equivalent to what? To 0. So we'll write there to which, okay, we have 3, which goes with what? With 0. No? The other thing that they gave you point prime. Point prime, guys, it's not x is to y, but it's actually x is to m. So it's a turning point, this thing. How do I know which is a turning point? Because when x is 3, the gradient is 0. When do we have a gradient being 0? Only at the what? At the turning point. So when x is 3, we have the gradient, which is m. So this one, it's x is to y. Ne? This one, it's x is to m. So you have x, which goes with what? With m. So once you see your m being 0, which is the turning point. As long as you can see your m to be 0, it means which you're at the turning point. What else did they give us? When x is 0, this is x is 0. Ne? What is your y? It's 27. So you have 0, which goes with what? With 27. And then what is this then? This is what we call the y-intercept. Yes. M. It's g prime. Once you see g prime, differentiation. When x is 3, the gradient is equal to what? To 0. That's what they are saying. What else did they give us? They gave us concavity, g prime prime. G prime prime is concavity, concave up, concave down. So when they say g prime prime is greater than 0, it's concave up. So when is the graph going to be concave up? G prime prime greater than 0. It's concave up. Greater than 0. When g prime prime is greater than 0, we're talking about concave up. When g prime prime is less than 0, this is concave. Concave what? Down. So when concave up, they say which x should be less than 3. Less than 3, should you are going to have 3, and then you're going to have values that are less than 3. And then for concave down, you're going to have x is greater than 3. They are going to have, for concave down, you're going to have x is greater than 3. For concave up, you're going to have x is less than 3. How will this thing look like? Let's go and check them. We expect this thing to look like this. X-intercept. We're going to start with the x-intercept. Our x-intercept, we have 3:0. Ne? So I come and shade here. Ne? And then we have our y-intercept. What is our intercept? Our y-intercept is equal to what? 27. We're still fine. So we have 27, and then we have 3 here. But we also have 3:0, which is a prime. This is the turning point. So if this is the turning point here, I have a right to say this thing here is going to turn here. Let's do it with a different color so that you'll remember. This thing is turning here. So it's either going to be looking upwards or it's going to be looking what? Downwards. Since there's only one turning point, they told us something. They said g prime prime of x greater than 0. X should be less than 3. Less than 3. Am I going? But it concave up. Igrafiam is up. Up when x is less than 3. So surely this side is going to be looking upwards. So here is looking upwards. And then but g prime prime of x is less than 0. Concave down when x is greater than 3. Greater than 3. I'm a values are greater than 3. This thing is looking downwards like this. Okay, so it's looking upwards, and then it's also going to be looking what? Downwards. And then it's going to pass through at 27. Here it is. It passes through 27, and then here it's simply going to go down. And then you simply extend. This thing is going down, and then here there's concavity. You should show the concavity. This one is up, and then this one is what? It's down. And then this is how we're supposed to draw our function.